Good evening and welcome to today's session. But before maybe we can start tackling what we are supposed to cover today, it is always good if we have a recap of what we learned yesterday. And with regards to that, I just want to pick Hein. If you can just take us through what we learned yesterday. And more specifically, I just want you to mention something that you learned, general knowledge that you gained, as compared to maybe trying to like something maybe that you didn't know and you think that you are able to get or to learn yesterday.
All right. I learned some interesting terms in the pre-processing space, such as class labeling for arranging data by category, the data cleansing, which is cleaning up inconsistent data, the data balancing is when you then when when you have unequal observations that might not be representative of the population. So you extract that, and then data shuffling and data masking for protecting private data.
Okay, thank you so much for that. Uh, Maybe I can pick another person to add. That is, I think, Wangui Kanyi. Can you remind us what we learned yesterday or anything that you learned yesterday?
Hello, can you hear me?
Yes, I can hear you.
So I'm sorry, I just joined, so I'm not exactly sure what has already been said, but I'll just say what I learned. So just part of the types of the pre-processing data, which is data preparation, class labeling, which is arranging data, then data cleansing, which helps to deal with inconsistent data, then data balancing, which is if there are some inequalities either in the number of categories of something, data masking just to make sure that the confidentiality is not compromised, but also it doesn't hinder the analysis and extraction of insight. Yeah, and the sources of data could be anything from customer records to historical price information, among others. Yeah.
Okay, thank you so much, Wangui, for that. Maybe I can pick someone else. Dennis, that's Dennis Odul. I don't know if you have ever spoken in this class since we started. I'm yet to know you all by name, but maybe Dennis, in case you are in yesterday's class, can you remind us what you learned?
Can you hear me now?
Yes, I can hear you well.
Um, we left something on sources of data, where we were talking about traditional data being from customer records, historical data, about customer IDs, addresses, and big data, majorly from we covered some things around social media, wearables, wearable tech, and such. And we also covered something around business intelligence analysts. They need they need to present their reports in a simpler and more understandable reports.
Yeah, thank you so much, Dennis. So yesterday, and I just want to emphasize on your last point. That was with regards to a business intelligence analyst. What came out clearly yesterday that irrespective of how your data is, um, and whatever you are trying to do, the objective, like you must be able to communicate in a proper way that can be understood. And we went further and said this can be done using dashboards that contains some graphics and so on, and summaries of the most important items that uh, should be reported. So maybe just a quick recap from my end. We looked at, I think yesterday we again started with data pre-processing, and we said this mostly assists us in making sure that the data is ready for other people to use. Then we looked at the common pre-processing methods that are used mostly. We talked about class labeling. We talked about data cleansing or scrubbing. We talked about data balancing. We talked about data shuffling. We talked about data masking. And I think here we took quite some time discussing on data privacy. But we will look into it again. Then we looked at where data comes from, and we looked by looking at two angles. That's the traditional data, and mostly we say that this traditional data comes from, like, it is a table format and is some kind of structured data that mostly we have in our organizations. After that, we looked at big data or non-traditional data, and we say that this data mostly is produced through digital platforms such as social media and so on. And that again brought another question to us, like, how are companies going to store all this data? And I said that nowadays we have what we call data lakes that can store both structured, semi-structured, and unstructured kind of data, as compared to the current. Most organizations have what we call relational databases that just store structured kind of data. Then we went further and looked at who handles data. We started from the data architect, and we say this is a person who creates a database. A database is where data is stored. And we say that these are people who create these databases from scratch. Then they design the way data is retrieved, processed, and consumed, of course. After that, we looked at a data engineer. Data engineer, what came up very clearly, we say that these are people mostly who do data pre-processing. Then as well, we looked at database administrators. We say that they control the flow of data in and from the database. But what came up clear is that with this emergence of big data, the role of database administrators is not very necessary nowadays, because all these processes can be automated. And in some organizations, I went further and said data engineers can do that work as well. Then after that, we looked at data science explaining the past, which we defined as business intelligence. And we say that business intelligence is most important because, first of all, before you start looking at what will happen in future, you must check on what happens in the past. Yes, Cyprian, I see your hand is up.
Sure. So maybe a question. So does that mean that what the similarity between a data engineer and a data scientist? Yeah, sure.
Okay, thank you. We are coming there, but a data scientist does all. A data scientist does business intelligence, does data engineering, does all those data science items. Like, as we define data science, we say that it is a wide field. So a data scientist even works as a machine learning engineer, and it is somewhere we are coming there today. Maybe you can understand it better. But for the sake of your question, is that a data scientist is someone who handles an end-to-end data process. That is maybe from a data scientist can build even databases, some of them, do data engineering work. After doing data engineering work, they do data analysis. After doing data analysis, they build these machine learning models. After building the machine learning models, they can deploy and so on. So a data scientist has that 360 knowledge with regards to data handling. I don't know if that is a bit clear, Cyprian.
Yes, it is, Xavier.
Okay, thank you. Yeah, then we looked at business intelligence. We say that this focuses mostly on using historical data to explain on what happened. Mostly business intelligence people do what we call descriptive analytics, whereby you are trying maybe to find out what was the mean sales, maximum, minimum, and so on, something like that. And then again, we looked at what do these people do, business intelligence analysts, and we say that these people, the objective is for them to analyze this data, create dashboards for the purpose of communication to the management. So I think today, now, we are supposed to start from where is business intelligence used. We have just a few examples that I have highlighted. And yesterday, again, we say that, yes, in business intelligence, we don't, the word data science does not appear anywhere, but we said irrespective of that, business intelligence is still part of data science process. So one of the things in business intelligence is price optimization. In price optimization, for instance, you can try to find relevant information in real time. Then you try to compare maybe that with what you had historically and so on. So maybe just to apply, let me give an example here that I'm having in hotel management and so on. You find out that prices of rooms are raised in periods when maybe there is high demand, and when we have low demand, you find out that the prices are maybe drop a bit. And maybe what these organizations can do at that particular time is to introduce some kind of, because the main purpose of dropping these prices is to attract people because it's a low season. And at the same time, they can try to they can try to run some kind of discounts and so on as part of optimization. Another thing here, maybe you are trying to make a decision what best works for you as a business. Maybe you have, especially this applies in logistics, people who are working in supply chain and logistics and so on. You have different routes. Let me use an example of a country like South Sudan, if I'm not wrong. They can use, I think, I don't know if Ethiopia has a port or it is Eritrea there, but they can use either the Kenyan port to transport their goods to South Sudan, or they can use, I don't know if it's the Ethiopian, I'm not sure, I'll confirm that. So you see, we have two routes. Both these two routes, you will have some kind of constraints, maybe the distance covered. You can have the another constraints that you can have, maybe some kind of insecurity and whatever along the way. So you are trying to find out with, you are trying to maybe minimize on the cost incurred and maximize maybe on the time, like the shortest time that you can use to deliver and so on. What you call the minimax processes and so on. We will get to learn them in the statistics. Another one is what you call inventory management. Uh, so mostly, if for instance you are working in sales department and you do some kind of analysis of past sales transactions, then you try to identify seasonality patterns and maybe time of the year with the highest sales. So when you are able to identify this, it results in implementation of effective inventory management techniques that meet demands at minimum cost. For instance, we all know that maybe during a rainy season, there is high chance that many people might purchase umbrellas. And during this season, normally it depends with where we are coming from and so on, like various countries and so on. But you find out that you have those specific months that you are able to predict that you are going to have maybe a long rainy season and so on. So in terms of stock, when you are selling maybe umbrellas, you know very well during that time, I'm going to stock a lot. So how now are we going to ensure there's a point here that I said that it results in implementation of effective inventory management techniques that meet demands at minimum cost. So as an organization, what you can do, you know very well based on past historical data and so on, that during this season, this is our demand. So maybe let us say you are a retailer or whoever and you are trying to purchase this from a wholesaler. So it means you are going to purchase these items in large quantities during a low season and stock them somewhere. When this rain season comes, you are able to sell at the market price and making very good profits as compared to someone who waits. The rainy season is starting maybe next week and you purchase today. It means you find out that the prices have gone a bit high. So basically, when you have this data, you do a proper analysis, you are able to find those what you call seasonality patterns, what can happen, and so on. But also, there's something nowadays very interesting, what we call the behavioral kind of science, that also has some kind of implications on data science processes, business, anything related to data. Sometimes when making a business decision, apart from just the results that uh, you are having, you are having in the your analysis, you have also to look at what is happening outside. Apart from just the data, it is something, it is a new concept that is coming up with regards to this in terms of the kind of people's behavior. We have some insights that you cannot extract. But as I said yesterday, also that nowadays you have metadata, you are able to extract using metadata to understand the customer very well. The customer might be thinking that they are submitting the ordinary kind of data, but in real sense, you are interested in the behavior, like how are they navigating your application, and so on. So you are able to identify and know this customer better. So another question is now, who does this business intelligence? So as I said, uh, in terms of roles, in business intelligence roles, one, we have someone we call business intelligence analyst. So this person focuses mainly on analysis and reporting of past historical data. They focus on this analysis and reporting of past historical data. Then in some organizations, you can have business intelligence developer. I saw one of the telcos in Kenya, I think it was Safaricom, that was at some point they were advertising for this role, business intelligence developer. So this person now um, handles more advanced programming tools. So you find out that, for instance, the the first case, the first person, the business intelligence analyst, mostly they work with very very simple tools like Excel, Power BI, Tableau, and so on. But a business intelligence developer, they handle more advanced roles. They can use tools such as Python, SQL. SQL, as I said, is mostly for data engineering. So it depends with how the projects that you are handling and so on. Sorry. Yeah, as I said that these people can even interact with more sophisticated tools and so on. So the next person is what we call the business intelligence consultant. Of course, when you start doing some consultants, it is believed that you have a lot of knowledge in certain area or subject and so on. So when you are talking about a consultant, it's just an external business analyst. Like you have been hired by a company for you to assist them in tackling that. So you find out that some companies outsource their data science departments. Maybe this comes in situations whereby maybe they don't need to maintain one. So as you see that a consultant, mostly their work is just to guide on how or what should be done and so on. So, sorry. Okay, just a minute. Just a minute. Okay, sorry for that. So I want us to look at the general career pathways in data science that you can come across. The first one is Okay, the first one is a data analyst. Mostly they do data manipulation and reporting. Sorry for the distractions. So data analysts, they do data manipulation and reporting. Then machine learning engineers, what they do, they create algorithms for data science processes. Then we have what called the data architects. I think this one, it talks about new database systems and performance improvement. Then we have data engineers. Data engineers, as we have said, they do batch processing and data pipeline maintenance. Basically, we said data pre-processing. Then we have what called data scientists. Data scientists basically do all this work, but mostly they do what call analyzing complex large volumes of data and support business decision making. And then business intelligence analysts, you have seen that mostly they deal with historical kind of data. That's what they do mostly. But normally, data scientists can do all this work. That's data architect. As I say that you'll be trained on SQL unit. You will be trained on SQL unit on how to create a database, mostly relational database. You will gain some data architect skills. Then machine learning engineer, you will do machine learning. I think almost the second, for those doing the certified data scientist, a half of the curriculum is, I think, machine learning. Then data analyst, you do the data analyst units. Mostly when we start the practical from R going to Python and so on, like data manipulation, data visualization, and so on. So we have data engineers. Data engineer, you will do like if you have some kind of SQ, you are having a relational database in your organization, and the company requires you to query maybe data directly from the database. You will have that knowledge on, you will be trained on how to link your maybe Tableau, um, Excel, and so on to link with the relational database. That is called now data engineering. Then business intelligence, as we say that this mostly you will look at historical data. Business intelligence mostly they end up on historical data. The only difference with the data analyst, a data analyst can do predictive analytics like forecasting what happens in the future. But a data analyst does not have a machine learning engineer knowledge like that is doing some kind of machine learning tasks and so on. So there's a difference. But now, when you become a certified data scientist, you do all this. You have all this. You are an all-rounded kind of a person. You can tackle whichever role that you are given with regards to data science. So maybe now that leads us to data science predicting the future. We have seen data science data science looking at the past. Now we want to see data science predicting the future. So when we are talking about data science predicting the future now, it brings us to what we call predictive analytics in data science. And this one rests on the shoulders of what we call exploratory data analysis. So we see that these things are connected, like these items are connected in an organization. We have seen data science focusing on the past. So once the business intelligence reports and dashboards have been prepared, and we have extracted those insights from them, that information now will be used, or they will form what we call a basis for predicting future values, because the business intelligence analysts, we have seen that they will do some analysis based on historical data and so on. That information now is what will be used to focus on the future. And the accuracy of these predictions will lie in the methods used. And this is where, again, where the data pre-processing part of it comes in. Like, in case you are having missing values, how are you going to deal with them? You are having inconsistent values and so on. So this is where like the business intelligence reports now will be used to look into the future. So we look now the difference between traditional data and big data in data science. So also here, when we are talking about predictive analytics, we are going to look at what we call the traditional data science methods versus machine learning. Machine learning is now the modern data science knowledge or methods, is what we call machine learning. I know this part now from here, it looks a bit technical. I'll try to be a bit slow. So traditional data science method, mostly they deal with what we call traditional data. And we say traditional data mostly is structured, right? We say that it is stored in a single computer. It can be stored in a single computer. But when we are talking about machine learning methods, mostly it deals with big data. And we say that big data, first of all, it is voluminous. Secondly, we say that this big data is unstructured and so on. And the main reason why machine learning is a modern data science method, um, uh, I don't know, during the first class or the second class, I talked about image detection like EKYC and so on. Like nowadays, what organizations do, they are trying to onboard customers digitally. So when they try to onboard the customers digitally, it means maybe you download a mobile application, then they tell you maybe to scan a copy of your identity document. After that, you are being told to take a photo or a selfie, then they try to match and so on. You see, the traditional data science methods cannot do that. That can only be done by modern data science methods, or what you call machine learning. Another thing, yes, you can have structured data. Structured data, there's some kind of structured data that traditional data science methods cannot do. Like you are trying to do customer segmentation and so on. Sometimes you need this what you call machine learning, which is modern data science methods. So when we are talking about the traditional forecasting methods, mostly they comprise what we call statistical methods for forecasting. Forecasting is trying to predict the future when you are having data. So The first one, of course, we learn this and also in machine learning is what called linear regression analysis. And I'm going to explain somewhere. So this kind of, or what called clustering and so on, this kind of methods are used mostly with traditional data. So, and I want to, when we are talking about traditional data, maybe we might as even the data, any data that we are collecting even currently and is structured and it is not voluminous, it is still traditional data. It doesn't mean when we are talking maybe of traditional data, we are talking maybe data that was collected maybe 1 year ago and backwards. No, we are talking even data that we are still collecting, but it is unstructured, so it is still traditional data. So we see this in some industries as well. They still refer these traditional methods as machine learning methods too. Still, it is part of machine learning. But when we are talking about machine learning, we are talking about newer, smarter, better methods, such as deep learning and one application of deep learning, as I have said, like image detection and so on, image analysis, such kind of very sophisticated machine learning methods. So I want now us to start looking at these traditional methods. You will do them practically in the statistics unit first, then machine learning again. It is part of it. That's why you need this knowledge. One of the traditional methods is linear regression. So to understand well what linear regression means, I want you to visualize there's this image that I have used in this slide. So when you are talking about linear regression, mostly we use it in quantifying what you call the causal relationship among different variables included in the analysis. Maybe to enhance understanding, I have an example. Like for instance, you can have the relationship between house prices, the size of the house, the neighborhood, and maybe the year built and so on. So what this linear regression does, it calculates what you call the coefficients. A coefficient is like a factor which you can predict the price of a new house if you have the relevant information available. Let me try to um, add more information there. What it means, I use traditional data, what I already have. Then I come up with a factor. Let me say, maybe when we are talking about, as you know, the house prices can change depending on the neighborhood, the year that it was built, the size of the house, and so on. So what happens? Let us assume maybe if the house was built so many years ago, it means this house prices might be lower as compared to a more modern house that was a house that was built recently, and so on. So what it happens now, we come up with a factor. Maybe if it is decreasing, this model will automatically, you will see it in practical, it will give you a factor based on the previous data. If the house prices will be decreasing, you can get maybe negative 1.2. So next time, if you have another data and you want to predict the future, I take that maybe negative 1.2, then I multiply maybe with 60,000 US dollars, then you will be able to predict the actual price in future. But this is one of the traditional methods. still used today as part of machine learning. Another one is called logistic regression. I don't want to go so much into details at this level, but logistic regression, what it does, we do have what we call binary classification, and mostly like financial institutions, they can use it in fraud detection. So what happens is that maybe you are having card payments, maybe a bank or a financial institution have card payments, then some kind of fraudulent activities happen. So you are able to have your data contains maybe payments that were accurate and those that were fraudulent. Then you will be able to classify if maybe any accurate transaction I give a code of one, any fraudulent I give two. So they are used to show what called binary relationship. And therefore, so what happens after I classify maybe fraudulent transactions and non-fraudulent, I'm able to come up with what we call a logistic, train my machine learning model using logistic regression and so on. So what this curve happens, it normally runs from 0 to 1. 0 to 1. So maybe I can come up now, I can calibrate my model by saying that if a transaction comes and maybe the performance is 50% and above, then that is a correct transaction, is not fraudulent, it passes. Anything that falls below that threshold is classified as fraudulent, and the system now automatically flags it off to manual approval, something like that. So that is what logistic regression does. I didn't want to go on the technicalities, but you learn in machine learning. Then there's another one called clustering. So clustering, mostly what it does is when you are having observations in your data that form groups according to some kind of criteria. So what cluster does, it takes account that some observations exhibit similarities, and therefore they facilitate the discovery of new significant predictors, ones that were not part of the original conceptualization of the data. So for instance, let us look at these examples will assist us mostly in understanding at this level. If you can see this infographic, like the graph that I have there, when we look at housing data, you can have some kind of clusters like small houses, maybe with you can have those houses that have, they are small houses but with a high price. You can have big houses that cost less, and you can have big houses that cost a lot. So like it is able to cluster, for instance, small houses with high price. Mostly these houses you find out in city center and so on. And big houses that cost less, maybe they are far away from the city center. And big houses that cost a lot, maybe you are talking about suburban neighborhoods and so on. So clustering will try to put those together with almost similar uh, characteristics, and you will also do it practically in machine learning clustering. Then we do have what called factor analysis. So we have seen that clustering, it groups observations together, but when we are talking about factor analysis, it groups features together. So let me explain generally. uh, um, let us say there's an example here. For instance, you have 100 item questionnaire, and each of the questionnaires pertain to a single general attitude. What factor analysis will do, it will identify maybe 10 factors, and these 10 factors can be used in regression and to deliver a more interpretable prediction and so on. But maybe to explain in another way, generally what factor analysis means in a layman's language is you are having data. The data has a lot of fields and you want to use it to make a decision. You are not very sure like which columns are the most important and so on. So what factor analysis does, it assists you scientifically to identify those features that are more important. That's what factor analysis does. Sorry. The last one in traditional methods is time series. Um, Time series, I think this is common, and it is a very popular method for following the development maybe of specific values over time. And time series is mostly used in economics and finance, because the most subject we are talking here is stock prices and sales volume. And when you are talking about time series, there must be a time frame, like these plots must have some kind of time frame and so on. And time is always on a horizontal axis, like it runs vertically. What we mean by horizontal. So for instance, such kind of lines just assist you to illustrate the behavior of your stocks over time. So when you and for instance study the visualization, you spot which stock maybe performed well and which one did not perform. As you can see here, we have three companies here. Maybe A, the red one is A. Maybe the other one is B and C. So you can see how the stock prices have been performing here. So we have the red one. This one is golden yellow, and this one, is it dark green or I don't know. I'm not very good in colors. But maybe from this observation, since I have talked a lot, uh, if you have been told to interpret this graph, that's the time series graph. Which stock have do you think has been performing well across? Do we have any that has been performing well? Anyone who can attempt? You can just mention the one with a red color or green color or golden yellow. Sorry, I think it is yellow. Just a quick one.
I think the one in green.
Yes, light green. Why do you say so? Can you defend? Can you defend your
Okay.
answer?
Because visually, when you're looking at it, if we had numbers on the y-axis, then the one in green could be taking most of the time. It will be having the highest numbers on the scale.
Yeah, sure. Thank you for that. I think that is so. That is what call time series methods. Since this section is technical a bit, I don't want today to go further. We are on course, but I just want us to, I want to give you an opportunity to ask questions. Then after that, today we will just end there and meet on Monday. On Fridays, as I said, we do not have classes, what we do have is community learning. And I'll be sharing the link to the community learning group in case you are interested to be joining, though it is still early. You can as well join tomorrow just to follow on what happens there. But it is not a must. It is only a must for those who have already graduated, because also you need the continuous professional development credits. Yeah, so any questions? Let me now give you an opportunity for questions. We have gone a bit technical today. Maybe somewhere that it was not clear. And I hope also you have these notes. Maybe you can confirm from your end the areas you have touched and not clear to you.
All right.
Yes.
I was wondering, can we maybe go over the traditional method, the factor method again? I'm just trying to understand properly how that works.
Okay. Thank you. So the factor method, how it works, let us say, let me use a simple example. Uh, and I want to pick a financial institution. Maybe if today you go to a bank, maybe you want to borrow a loan, they'll do some kind of underwriting. If I'm not wrong, they will take like some kind of details from you, your gender, they look at your income capabilities, they look at very many factors about you. But you see, all those factors or variables about you might not be having the same weight in making a decision. Maybe out of those, only two are necessary to prove that you have the capacity to pay the loan and the willingness. You have both the willingness and capacity to pay a loan. So what factor analysis does, it assists you, like the decision, someone who is not, you are not sure which among these items or variables that I'm using can assist me in making a decision or can be used for further analysis for the sake of making a decision. So factor analysis assists you to come up with those variables. Among many, it picks a few for you. So that's how it works. Is that clear, Hein?
Thank you. Yes, that makes sense.
Okay. Any other question? Yeah,
Sorry, sorry,
Cyprian.
my data was clicking on my computer. But I want to ask if the factor analysis is quantified or qualified.
If it is,
Uh, can you hear me?
yes, I can hear you.
So is factor analysis quantitative or qualitative?
It is quantitative. Quantitative.
Okay,
Yeah.
thank you.
Okay, thank you. There was a hand from Cyprian.
Maybe can you reiterate again about the community learning? Seems I missed that. So
Oh,
yeah.
okay. So community learning, the objective is just for graduates, students, and anyone who is interested to cement, let me use that term, like if you are interested to become more confident in your skills, It is an opportunity for you to work as a team, to collaborate with your colleagues, to tackle various projects that cut across various industries. Like currently, the last project we finished was on using AI to improve health access in Kenya, in Africa. The current one that is ongoing, tomorrow we will be starting building the machine learning models. We first of all, we did data cleaning, we have done exploratory data analysis. Tomorrow we'll be starting building the models, and if we finish tomorrow, then next Friday we will be deploying the model. So basically, it is a platform for you to gain more skills by working on various projects. As we know, like as you work for many projects, you become more confident and in whatever you do. So that's the objective of the community learning. Cyprian, is that okay?
Yeah, that is okay.
Okay, thank you. Any other question?
Same time or different time?
Community learning is the same time, but it runs for 1 hour only.
Okay.
Okay, thank you. So, what you can do, I know most of you are working, and maybe you might have not gotten an opportunity to go through whatever we have covered so far. And that one sometimes can lead to maybe us not having a lot of questions or seeking a lot of explanation, something to be explained. So if you can, before we come back on Monday to continue with the next section of the unit, this course, you can try and skim a bit on whatever we have covered so that you are able to understand. Yeah, I shared all these notes. I don't know if you received. I shared in form of a PDF. I shared the notes. Maybe I'm going to run a poll in the group to see who got the notes and who did not. But in case you did not get, just inbox me. I'll reshare. But I shared the entire. Yes, hey.
I'm sorry for that. Yeah, I saw. I didn't realize it was the full document that you shared. I thought it was just for the previous class. All right, now I got it.
Yeah, yeah. It is there. Everything is there. It's the same document, but I converted into a PDF. Okay. Thank you guys for attending today's session. So before you sleep, as usual, you will get the recording. Bye. See you on those who will attend the community learning tomorrow. And in case you don't attend, we meet on Monday, same time.